Alright, let's see how this goes. Let's see how it goes. Are we live? I think we're live. I think we're live. This is exciting. Can I listen?
Alright, we've fixed the echo. We're in. Now we listen. Where do I copy my stream link? Where do I do this? Cool, we're gonna get started really soon. I just need to share the link somewhere. And then, oh, I need to take this out. I need to take this out of my ear. I need to get a better thumbnail. Holy crap, that is awful. Things to know for next time. Things to know for next time. Let's go trying. Announcements. Red circle. Love it. All right, this looks good. This looks good. I think we've got everything under control. I think we've got everything sorted. Let's see how we go. Game Dev Unity, hello, welcome. First stream on YouTube, let me know if there's any technical issues. Otherwise, we're going to blast in. We're going to start talking about some PlayStation 2 Homebrew. Let's start at the logical place. Let's talk about what currently works, okay? So, this is my top-down PlayStation 2 adventure, you know, tile-based renderer. There's not much to talk about, right? We're starting really, really simple. There's going to be a lot of stuff. There's a lot of stuff I want to do on the PlayStation 2. I want to do 3D, I want to do complicated stuff, but for now, I just need to know that I can really nail the basics. And so we've got this top-down thing, and I've been building a system for editing levels. You can pull up a little tile map. You can put down tiles. You can swap between different tile layers. You can eventually, potentially add and remove tile layers, which would be cool. Where are we? You know, you can just like go into the upper layer. You can put down flowers and stuff that overlays. Nothing too exciting to write home about. I've actually added, since my last stream, the ability to change the debug level, or the log level rather, from the actual editor, so that when you're going around placing tiles, you don't have to deal with all this spam. And if you want to just dump out like a couple of frames worth of graphical data, you can turn on trace logging, which logs a lot of stuff. So that's kind of cool. That means I can do that without having to restart the engine, which is nice. And saving and loading of these tile maps does actually work, but I haven't shown it on stream yet because it's a little bit tedious. It's a little bit cumbersome. Fireboys, long time no see, thank you. Welcome. It's exciting to be back streaming a bit. Let me just make sure I actually have chat up somewhere I can see it. And then today, the topic of the stream is going to be managing VRAM, which is fun, right? The PlayStation 2 doesn't have very much VRAM. Essentially, our whole engine on any given frame is going to have about 2 megabytes of VRAM to work with at any one time. And so that's not a lot of VRAM. That's going to be hard to do. So we're going to have to do something clever to juggle VRAM. Currently, I have a rough attempt at streaming different zones of the game in. I call them scenes. So you start in this scene that we can see here. As you move to the right, it should load in a second scene. We can actually see that this doesn't work, and there's actually just a black void that you move into forever. And if we keep going forever, it's going to try and load in the scene after this one that currently isn't drawing, and VRAM buffer overflow. A very scary sounding message. And that's because we've tried to load another tile set. In this case, it's the same tile set. Unfortunately, I don't have more than one tile set kind of ready to go at the moment, so we're just going to have the same tile set twice, but for each scene, even if they have the same tile set, they need to be able to allocate that asset in VRAM. Currently, when we try and do that, we run out of VRAM and it's a hard crash. You can't, well, we can recover from it. I probably could be a bit more graceful about it. I currently don't have a handler in place in my game logic to support recovering from an error like this. What thing to do? Yeah, so we're doing VRAM. We're doing VRAM, okay? So we need to stop this happening. We need to stop crashing when we run out of VRAM. So let's just open up a little thing. I'm going to draw some pictures for you about how this should work. Actually, I think I have a template still for this, right? Yeah, beautiful. Nice. Okay. So this is, let's draw VRAM, right? This is VRAM. And the PlayStation 2 has about 4 megabytes. Oh dear. Has about 4 megabytes of VRAM. Except we're drawing it 480p. And this VRAM area has to contain the frame buffer as well. So as just a rough rule, we're going to say about half of this 4 megabytes. I don't know why this mouse is so jittery. We'll have to... Hello? Have to see what we can do about that. Half of this 4 megabytes is just going to be taken up by the frame buffer. We can't touch it. Let's call it FB, right? So this is just what we render to while we're actually drawing our scene. So we can't use it. So we have about 2 megabytes left over to actually have all of the assets that we need to draw any given moment in the game. And before, I actually said that we had 2 megabytes per frame, but that's not really true. The PlayStation 2 has this cool little quirk that lots of games, if not every game, has to take advantage of in order to actually draw anything with 2 megabytes of VRAM. For reference, right, I'm crashing when I try and load in two 512, so 2x 512 by 256 textures, 32-bit. So, which is very unnecessary, but you know, we haven't compressed them, we haven't done palettes and stuff. This is too much. This is the condition that's currently crashing our game. Actually, maybe it's 3 times, 2 or 3 times. The point is, we should be able to handle this. And especially if they're in kind of discontinuous, or like continuous parts of the game, but distinct parts of the game. It's a tight constraint, Toffee. Yeah, thank you. It's fun, but we're gonna see there's actually a really cool way to handle it. So the PlayStation 2 has low VRAM, but high bandwidth. Probably didn't need to write this out. Let's go back. I'm getting too excited. I'm treating this like a whiteboard, but it really isn't. Mice are not equivalent to whiteboard markers. So every frame, we can stream all of these assets into this 2 megabytes several times. I think theoretically the bandwidth size, like the bandwidth per frame or per second, it's 9.6 gigabytes a second or something off the top of my head. It's over 9 gigabytes a second, which gives you a lot to work with per frame. Currently, my strategy is each scene in the game has a list of assets that need to be in VRAM when that scene is drawn. So on draw, we always upload all assets, which is at most 2 megabytes, right? So upload all assets to VRAM, upload them to this 2 megabytes, and then render. That's it. That's all we have to do. So you take this complicated problem of like, how do we juggle, how do we allocate and deallocate from VRAM and all this hard stuff, and we just say, forget it. Every time we draw a scene, we upload all of that scene's assets into the 2 megabytes of VRAM, we saturate it as much as we can, and then we draw everything in that scene. And then if we have to draw a second scene in that frame, we upload all of that scene's assets into VRAM, and then we draw that. This incurs a pretty, like a not insignificant overhead, but I mean, if we're still within, 60 frames a second, that's fine. I don't care. I'll be a little bit inefficient if it makes managing this stuff easier. This kind of shortcut is going to get more and more important as we move into 3D, because VRAM management is just a nightmare. If we can make an assertion up front that makes our life easier, that's going to be really, really good for us in the long term. So, scene, list of assets, every time we draw it. But then we also have to know where we put it in VRAM, right? A scene has to, the textures in a scene have to live somewhere in VRAM. And the way our VRAM allocator works, well, it's just a number, right? It's a number that starts at 0 and goes to 2 megabytes. We allocate the frame buffer out of this. So this is our VRAM. And we have an abstraction called a slice. And a slice just says, take a subset of this range, and this is your new range. So for example, sorry, this should be a 4. Let's just sneakily, hello, which button do I need to press to make you delete? Nope. Let's just get the eraser. Here we go. No one saw anything. Perfect. I should have made this bigger. 4 megabytes. So a slice, for example, we can just say that for a scene, maybe we have, you know, A to B. And then we can allocate out of this slice some n bytes. All that does is update the slice. Let's say slice prime equals A plus n to B. Let's turn these into arrows so it's a little bit more obvious. So this is the abstraction we use for managing VRAM. So basically the conclusion of this is the game needs to know how much VRAM it has for drawing a scene. I'm so sorry that keeps happening. I keep pressing X instead of Z when I try to undo. So the game needs to keep track of how much VRAM it has. Each scene is going to share a VRAM slice, or they're going to have their own copy of a VRAM slice. So they can all allocate their assets against a version of the same range. And because every time we draw something, we upload all of the assets to VRAM, you know, every single time, scenes never actually co-locate the same VRAM. We can allocate assets into the same range of VRAM. Because we upload all of the assets before we draw anything in that scene, it's fine. We can allocate, we can double allocate into that range, we can triple allocate into that range, we can have 100 scenes that have all allocated into that range. They never actually contend with each other. The cost we pay for that is that we have to upload all of the scene's assets into VRAM every time we draw it, which isn't insignificant. So we temper that cost by only drawing at most 2 scenes at a time. Perfect. Perfect. That's our plan. That's what we're going to do this stream. So let's head over. Let's get rid of this. Let's call it VRAM. Let's make a branch. Let's make a branch. Cool. So in our main file, we do a lot of setup. We do a lot of stuff. We have this really janky interface, right? We make a game. We have our game global state magic variable, and at the moment we just hard set a field in it, and we set it to this VRAM slice, and this VRAM slice is just saying, you know, take all of VRAM that we haven't used so far. So from the current head of the kind of global VRAM slice, anything we haven't allocated frame buffers to, this is what the game has to work with. Then when the game loads, actually there's something else that happens. Is there? Where does the font get loaded? Yeah, there's also a font that gets loaded into VRAM. Where does that happen? The font gets loaded into VRAM. The font gets loaded into VRAM down here, which isn't good. Okay, this is gonna be the thing that catches us out most. Because we want to be able to draw text on the screen, fonts need to live in VRAM. Where in VRAM do we put fonts? That wasn't part of my design. We'll come back to this. We'll revisit this. We'll sort the game interface first. So game.lua. The first thing we need to do is have a better way of passing in the actual VRAM range to our global game state. I don't know why this is like a little bit... Is that? Oh no, that's fine. That's fine. Okay. This is just like stretched weirdly. Annoyingly, I didn't make this transparent, so we're just going to quickly fix my stuff. Cool. Okay, there we go, there we go. Lovely. So, game. The kind of our game global state. The way we currently manage it, we have an A scene, we have a B scene, and we have a C scene, which is smaller, so I'm going to draw the C smaller. A and B are the 2 main scenes. We only draw one of these at a time. You can only load... So one is active and one is inactive. Let's say, you know, you have one active and one inactive. You can only load new stuff into B while A's active, and then if A becomes active, you can only load new stuff. If B becomes active, you can only load new stuff into A. Only load into inactive scene. Scene. Always render. So we only render what's active. The inactive one we change around. That's kind of our magical box where we load new data. And then C is the connector between these two scenes. C is always drawn no matter what happens, and it's up to these two scenes to kind of negotiate what scene C should be. It kind of puts all of the onus on making sure that smooth scene loading works on the actual level designer, which isn't great. It's not a super flexible system. C always drawn. Always drawn. Small. Okay, so A and B share VRAM. C, because it's drawn at the same time as either A or B, probably could have its own VRAM. So all the stuff I said back on page 1, this kind of refers to A and B, right? C in this equation is a slightly different thing. Cool. And C is the connector, I guess. Right? So if I were to draw a picture, let's say we have a room, and then you have a little bridge between it, and then another room, and you probably have some kind of magic line at some point here that says, hey, you know, load this to inactive, right? So in this example, this would be your A, this would be your B, and this would be your C. You always draw C, no matter where you are in A, no matter where you are in B, but if you're in B, you stop drawing A, and if you're in A, you stop drawing B. At some point here, you kind of like swap with what's active as well. So I guess, you know, you would say swap. Right, once you cross this line, B becomes active. Once you cross this line, A becomes active, and you can't see them from each other. So that's kind of the goal of C, right? It's the buffer zone where you can only see at most one of the two scenes that are kind of adjacent at any given time. So the point of all this is, A and B, well, the game needs to divvy up its VRAM. A and B have the same slice of VRAM, so let's say the game gets this VRAM. It wants to take a slice off for common things, e.g. font. It's going to take a slice out for the connector. And then the rest is going to be shared by A and B. And by shared, they're both going to use the same range at the same time. So, game new. It's now going to take in a VRAM slice. Now, the actual VRAM implementation is not in the source tree for this repository. I'm going to hope that we actually have everything we need. Where are we? VRAM. Do I have a copy? I don't have a VRAM copy, which is annoying. Frame buffer, texture, slice. Okay, so I can call VRAM slice. I can hack this basically. Yeah, cool. So we have one like big shared slice of VRAM, which is just the entire range. Cool. So then what gets passed into the game. We want to take something out for common stuff, including our font. I don't know how big that should be. How much space does our font take up? Well, I guess we can check, right? Spleen. Bigfont.tga, 65 kilobytes. I really need to squash this down and make it palletized or something, because that's a lot for a font. That's a lot for something that's always going to be in VRAM. Let's go game. Let's make it 66K, so 66 times 1024 local. The connector size, actually, you know what? Let's say the connector shares it as well. Let's say the connector has the same slice of VRAM. That makes way more sense. Are people following this, by the way? If you want me to stop and slow down and explain stuff better, just shout. That is absolutely fine. I'm just kind of going, right? I'm just here for a good time. I was gonna be doing this anyway. I may as well talk about it and have some fun sharing it with people while I do it. But please feel free to ask questions. I've changed my mind. I think it's actually going to be simpler if I say that, oops, this is shared A, B, and C. Beautiful, high quality, different pen size. Perfect. Love it. Okay, so this is all going to be shared. The rest. So, font slice. It's going to be our VRAM slice dot. Where are we? Dist. Okay, we actually have to do this a kind of weird way. So I need an API to do this better. Let's say... Actually, you know what? I'm gonna... How do I do that? Do I say copy and then give it a size? Do I say copy and then change the... Do I need an interface that's gonna let me make a subset of a slice. I actually currently do not have this. I've only got the function that creates... I guess my intention was that I would say VRAM.slice, VRAM slice dot... Is it head? Is it start? Address? Start? Tail, yeah. I would say VRAM slice dot start plus font size. The problem with this, I think, is alignment. Although everything we allocate from it gets aligned. So I guess this is okay. So then we'll say local scene slice is VRAM slice the next byte, and then we'll go all the way to VRAM slice dot... Did I say end or tail? I've already forgotten. Tail. Start, head, tail. I think my terminology here is a little bit inconsistent. I think it makes it a little bit hard to follow. I think because head is the current thing I'm allocating from, but start is like the start of the slice, the end of the slice should be called tail. It should be called end, not tail. It's like the start and the end, and then the head is the thing that moves in between the two. Head and tail makes it sound like they're the bounds, and then start is the odd one out. But I don't think that's too important. Okay, so make two slices out of this, and then we're just going to set them in the meta table here. We're going to say font, or let's say common slice is font slice, and then scene, let's call it VRAM equals scene slice. So we give it one big VRAM slice, we cut it in half, we cut it into some arbitrary division, and then this is what we allocate with. So everywhere we reference VRAM, everywhere else we reference VRAM, this is going to be gone. We're going to say common slice and scene common VRAM is nil, and scene VRAM is also just going to be nil. We'll get a nice nil pointer exception. And then we actually don't use this again. So this is kind of concerning, right? Where else in the code are we touching this VRAM? It's not obvious. We don't pass it anywhere explicitly. It's kind of passed quietly. So, and what happens is in this reload method, things are referencing VRAM. So what I probably should do is is this, maybe? Actually, no. So there's one piece of the puzzle that I've kind of talked about. The fact that both of these scenes are going to be sharing the same bit of VRAM, right? They're both going to be filling it up. It's kind of like scene A is going to be filling it up in blue, and scene B is going to be filling it up in green, and it's completely fine that they're both filling up the same range. The thing that's missing right now is that if they both allocate something from this slice, it's the same literal Lua object. So what we need are three copies of this slice. One for scene A, one for scene B, one for scene C. When scenes get unloaded, we reset the allocator. When they load in, they allocate things against it. I hope that makes sense. We're going to have literally the same start and end range, but they're all going to allocate against them at the same time, and then we just need to be a bit smart about when we actually reset them when they want to allocate more things. So we have this scene slice, then we're going to say local scene, or I guess let's say scene A VRAM, and we're going to have something that can copy a slice. The other thing we probably need is a reset method. Currently, the way you would reset the allocator is just by setting the head back to the start. But it would be nice to have, like, later on we could do self scene A VRAM reset, and just have a little utility that did that for us, so we don't need to leak the internal field names out to the wider world. That'd be good. I always forget I have a right-click menu in NeoVim now. It's kind of nice. I also like that one of the options is how to disable mouse. Okay, so. I'm gonna add this to the meta table just in my local code for now, and at some point upstream it. That'll be good. That'll be fine. So now when we load, we need to say function game get scene VRAM if self.active scene active scene A. So if scene A is active, right? This is where is the arrow pointing, A or B? If scene A is active, then return self.scene A VRAM. I will do the same thing for get connector VRAM. We just return it. We probably want to check if the scene is currently being used. Like, if scene C is in use and we're trying to get the VRAM to do stuff, then we probably want to log an error and just say, hey, probably don't want to use C's VRAM while it is active, because that's when we're going to override things, mid-frame or something stupid. Return self.scene C VRAM. We're not going to actually crash here, but we're just going to log it, and if that log message shows up and we don't want it to show up, we'll just get rid of this line. But I suspect if we see this, something's gone very wrong. And now we also probably want the opposite function, right? Game get inactive VRAM, which, if we're loading in a new scene, we can use this method to get the VRAM slice we should be allocating against. I don't know if this is going to be watertight in practice, but let's find out. And that's going to be the same function. It's just going to return the opposite of the previous one. This is really fraught with danger. The fact that I've had to write this if statement so many times just makes me get scene other. I should be consistent. Get VRAM other. I'll try and be consistent with my names here, but the naming is a bit of a shambles. But it feels like there's two contexts that are going on, so maybe I need a context A and a context B, and a smarter way to resolve this. And I could probably actually do it with Lua metatables in a fun way. That would be cool. Del, welcome. Thank you for stopping by. Good to see you. Thank you for the welcome backs. It's good to be here. It's good to see people stopping by YouTube. I wasn't sure if anyone had come watch here, or if it was a Twitch-only thing. You have a PlayStation 2. Clambone says they have a PlayStation 2 that can boot ISO files. Is it possible to make a game and run it on a console that can do so? Yes. If you can run, like, if you're using, you know, Open PS2 Loader or something to launch ISOs, yeah, if you're using a mod chip to run disks or whatever, you know, absolutely. As long as you have a way of running Homebrew, you're fine. There's a program called wlaunch ELF, which, let me just... I think you can kind of see behind the magic of my fake window manager here. But this program is a Homebrew launcher. If you compile anything to an ELF, you can just launch it. That's how I run my Homebrew. It's a cool program. Highly recommend it. But yeah, so if you have a look, let me just... I've got an ELF file. Any Homebrew launcher can just run it, and then my game just runs, which is cool. Do I have 2 instances of NeoVim running? I think I do. I do. I forgot I have one, like, Control-Z'd. That's okay. That's okay. Okay, so now we want to find wherever we've referenced this kind of game.vram that no longer exists. Common VRAM, scene, a VRAM, B. However, if you're embarking on a quest to write PlayStation 2 software, be warned, it is a dark and perilous journey. Yeah, Dell, what was my motivation for making a PlayStation 2 game? From what you can tell, it's super difficult, but it looks like I'm doing it with ease. I'm not doing it with ease. I started this journey back in 2020. It's been slow, it's been painful, there's been blood, sweat, and tears. You have to be very comfortable with the low-level hardware constructs. You know, I'm building, like, I basically had to write a GPU driver. I'm building all these complicated draw commands and buffers and sending them off to the PlayStation 2's GPU to render, to rasterize. Concepts like, you know, working around limited VRAM and stuff. You just have to be a little bit creative. You have to be prepared to read a lot of documentation about how the hardware works, come up with some fun, creative solutions. But really, you know, I just love the challenge, right? I grew up with the system. I would love to build something 3D that, you know, was a little bit more interactive than what I'm currently doing. But this seems like a good step to get there. You know, play around with the hardware, understand limitations, do some, like, dynamic level streaming. Maybe one thing that would kind of be fun to play on top of this system, the way I built it, is, you know, you can dynamically load and randomly generate a level. So I could have an overworld that I'd, you know, placed every tile of, but then have offshoot areas that just kind of randomly get generated. Good way to compress data as well. Yeah, so you know, experimenting with a few things like this and seeing how then I can translate these ideas into 3D, because this system of having an A buffer, a B buffer, and a connector, I'm pretty sure Andy Gavin has talked about how this is how the Naughty Dog games worked on the PlayStation 2, right? They would just, you'd have 2 main buffers that were mutually kind of, you know, exclusive, and then you'd just have a little bit that was shared between them, and your levels just had to be big enough, small enough rather, that they would fit, or your level chunks had to fit into one of the more restricted buffers. It's a large restriction on yourself, but it just makes your life really easy. It makes juggling really easy. So yeah, I don't know. Challenges are fun. I love the console. I love reading stories about how people worked around the PlayStation 2's limitations, and no one else is doing it, so hey, why not? Okay. So let's go into... Let's look at my test room. This test room's interesting because we load it as if it was a, you know, kind of hand-built level, and then we can save it and load it as a hand-built level, but the actual code that loads a hand-built level considers itself a totally different scene to this one, so it's a little bit janky. It's a little bit annoying that we have to do this twice. So... Okay. So we call scene reload. Get scene. If scene is not nil, then we unload it. So when we swap scenes, we unload, we reload. When we reload a scene, before we do anything, so we want to grab scene, the actual implementation of this. Just as a quick side note, scene is like the parent container, right? A scene is a thing that we draw, that we interact with, that contains entities, that contains gameplay elements. And a scene can be reloaded and it can be unloaded. It can never just be plain loaded. I decided to go all in on calling it reload rather than just load, so that it was kind of re-entrant. There was never like a start loading. It's just, hey, load all your assets right now. Maybe that gets called more than once. You have to write your scenes to be prepared for that. The way we'll deal with that in VRAM is every time this gets hit, we clear VRAM and we start from scratch. Cool. So from the game, we're gonna say, so we spawn our entities, etc. Let's go local VRAM. The VRAM slice is gonna be get VRAM other, kind of like the back slice, VRAM clear reset maybe. And then we call on reload. Let's pass the VRAM in explicitly as well. Yeah, I like that. I like that. So then we're going to change this signature. We're going to put an explicit VRAM thing in here. And now, rather than this, we just do this. Cool. And, you know, all this does, like, this has one hard-coded texture, and it just force allocates it into VRAM. It's not that bad. Cool. Fun question in chat. I'll get to it in a second. Cool. So I'm going to do this one more time, just really quickly. We're going to go into editor zone. So editor zone, this file is the things that we load and save from the editor. And so this is just going to be the same thing. It's actually not that complicated. And at the moment, we just hard code the resources to be this one tile set again. Eventually, we will actually make this something that we can save and load, right? We can have different sets of resources that, you know, are associated with different areas that we build. Cool. So this is good. This is good. VRAM connector. The connector, we don't actually set this connector to be anything here, which is interesting. If I run this right now, it's going to crash. It's going to crash because there's something that isn't defined. Room.test. It's going to crash because there's a syntax error, which is fun. So let's just run our Lua syntax checker. Let's run it on our source directory. Okay, well that looks okay. We'll investigate that in a second. Clambone says, is there a visual world that you see when typing this code kind of like Unreal, or is it older than you're thinking? There were visual editors and like tools with you know, like yeah, tools with good visual editors and stuff in the PlayStation 2 era, or like, you know, fairly out of the box solutions. Unreal Engine, some early version of Unreal Engine must have run on the PlayStation 2 at some point. But no, this is all custom, right? This is all stuff I've built basically from scratch, basically from, like I said, building the commands that actually get sent to the GPU. So I'm building a level editor that I can interact with, and I've built my Lua code in such a way that I can hot reload it while the game's running on real hardware, which is cool. As long as it's, you know, running over a network or something, as long as I'm connected to my computer in some way, tethered to reality. But no, there's no out-of-the-box, like, world-level editing solutions. I put a lot of work into this code base already to actually building an editor, and I'll show it off again in a sec if you want to see it. Very, very bare bones, right? 2D, tile-based, very simple. But yeah, I've had to build all of that from scratch. So I'm building my tools and my asset pipeline, really, along with the actual code. Shim.lua, by the way. This is actually a fun way to do this. I didn't address this, but I wrote a Love2D wrapper for all of the PlayStation 2 stuff, so I can actually run this just in on my PC. Let's not run another instance of NeoVim. We've already got two going. I was referencing a variable that didn't exist, which is good. Attempt index VRAM slice and nil value. Okay, 119. So we've got an error. Font size +1. Font slice. It said font slice, right? Index of nil value, VRAM slice. VRAM slice and nil value. Game new. Because we're not using game new, are we? Or we're not passing anything into game new yet. Yeah, here it is. Cool. So we're not going to initialize our game until later in this process now, which is good, which is actually really, really good. Again, we're going to have to rethink this font thing, but that's okay. Game equals game.new VRAM mem head. Cool. A number value. Awesome. Okay, so now we're into the part where we're hitting methods that we've just kind of made up that don't exist yet. So if I go to game.lua, this method, I just made it up. Doesn't exist. So we need to just define that right now. Like a boss. Ooh, got shading working on a PS2 yesterday. He wants to make Portal on a PS2. Gonna make a YouTube channel for the devlog. He's gonna render Portals on the PlayStation 2. That's exciting. So shading on the PlayStation 2, so just like what, like depth-based shading or something, right? Like what, like primitive, like almost lighting but not quite. I don't know, lighting code is going to be really fun when I get around to it, right? Because you have to do your lighting calculations. You probably want to be able to do them on VU1, right? And you're just doing vertex color and just dealing with however janky that looks, which is cool. Portal rendering on a PlayStation 2. Okay. So are you managing just a lot of different draw buffers? And like, you know, rendering, like if there's a portal in your scene, render to some like frame buffer off camera and then render that buffer where the portal is? Like Vertex but using Garage. Yeah, okay. But lerp what, right? Because you can't do per fragment shading on the PlayStation 2, right? There's only vertex operations. Like, what is that? I mean, the rasterizer actually supports it, right? Like, it's not something you control yourself. Okay, so we want to grab lerp. Yeah. So the PlayStation 2 does the smoothing and stuff and makes it look nicer than just like pure vertex color, but like it's not proper. Like you can't write a fragment shader that does anything else. You can only set color values per vertex that you send into the GPU black box. Yeah, we're agreeing in slightly different ways. Okay. Annoyingly, I just don't want to add this here. I just don't want to add it here. So let's do something dumb. Let's make a function. Let's go m.copy is a func. Because Lua is just really janky, we can just extend classes whenever we want, which is cool, which is fun. Okay, so copy, we're going to return... this is annoying. VRAM... self.start, self.tail. And then m.reset is going to be a function. We're going to say self.head is 0. is self.start, sorry. Because start head is not an offset from start. Head is an actual value. Okay. Cool. So we're gonna get we're just going to casually extend how this works, and this is going to be a very local function that we'll delete later. Nice. Like a Boss says he learned a lot from watching my videos. I love to hear that. That's really cool. It sounds like you're doing some interesting stuff. Please share it. I've got a Discord server. If you're not in it, come and post screenshots and stuff, because that's what I want my Discord to be. I just want it to be cool stuff people are doing. Create invite. Let me just drop a link real quick. Would love to see some video, would love to see some code, you know. Come share what you're building. So this still says it's a nil value, which is annoying. I thought we could just freely mutate a meta table like this. One of the cool things, by the way, with my VRAM abstraction just being 2 numbers is that it was really easy to write a shim for Love2D. And Love2D actually detects when there are VRAM leaks, but also is not limited by 4 megabytes of VRAM. I could, in theory, just give this a much bigger slice and it would be fine, but I can also catch VRAM leaks in a simulated environment. That's pretty cool. Let me just maybe like print m dot, what's a function in VRAM? Well, but it's not, VRAM.mem is a slice. So actually this should be, so what we have here, what m is the metatable for the VRAM slice. So in other words, this thing, we should have a reference to this. So let's say alloc. Let's print whatever alloc is, and we expect this. We're just going to do a bit of debug printing, which is great. Concatenate alloc a nil value. Okay, so we've got the wrong thing somehow. Okay, question 1, does get metatable not work the way I assume it does? Have I made a dud assumption? Did I just move? I just moved this to the wrong. There we go. Have I made a bad assumption? That's not correct. Okay, this isn't what I want. Let's try this. Operations. Get metatable t. We use set metatable to set or change the meta. Yep. But can we use get metatable to modify the metatable? That would be good. That would be good. Surely. Use a meta field also. In this case, to protect metadata. Okay. That's fun. We probably could do that with my library code just to stop people shooting themselves in the foot. Might be nice. Might be nice. Okay. This is annoying. Why is this not? So this is a table, right? We've actually got a serialization library that I pulled in now. I wonder what m looks like if I serialize it. That would also be a clue. Copy a nil value. Got a thing. We've got a table. I just don't know what's in that table. What about instead of alloc? What's... So this is the slice. What about the actual, what about a method on the actual VRAM object itself? What about size? If it says this is a function, then we've just grabbed the wrong meta table. Nope, still nil. That's really wild. Like, we've got a table. It just can't, I just can't work out what this table actually is. It's very upsetting. It's very disappointing. I don't want to get bogged down in Lua details too much. Nice, nice, nice. So we've got a table. We've got a table. But what does this table have? Okay, I'm gonna... let's grab a serialization library that we're using. This is really dumb, okay? But I want to work out what I've got here. And we have serpent.dump. Okay, let's see what we get. Not what I wanted. Start frame buffer equals blah blah blah. Okay. Frame buffer equals start. So this looks like we have a start, we have a debug information, load, allocate texture and self. Yeah, this was more serialized than I expected it to be. But it definitely has a start and a tail and a head. Huh. Definitely has a start and a tail and a head. So then why can I not? Alright. I might just have to do the dumb thing and nah, okay. I'm gonna give up on this for now, but we'll come back to it. We will revisit this. We will do this smarter eventually. And we're just gonna make a silly let's go scene slice dot reset. Okay, let's do it here. Let's do it here. Is function self dot, so it's going to be a function, so we can copy a copy a copy. It references self properly. That's good. Self dot start, self dot tail. Cool, and we have VRAM included. This is good, this is good. And now we just need to copy VRAM. Let's just go function. Let's go scene, slice, copy. No, but that doesn't work. Okay, this is where, and also once we copy it, this no longer has this. Okay. I'm tying myself in a knot. I'm tying myself in a knot. I'm gonna do the obvious thing and just set it here in the actual out of tree code. VRAM slice reset self dot head is self dot start and now when we run this, everything's almost okay, but that's not how we reference things internally. Now we're getting somewhere. Font to VRAM no longer works because when we come in here, we try to load it to VRAM like this. I think we might just get rid of the concept of the font existing outside of the game. I think the game just might have to own the font, and that's okay. Font new, font texture. This is all good. The editor can hold a reference to the font from here. The game just has to... Okay. Okay, I've got a plan. I've got a plan. I've got a plan. I'm gonna do another hack, but it's gonna be a less bad hack. Clambone, by the way, did say, trying to see the next Barnyard or Scarface. Yeah, of course, love the Sly and Jack games. Sly Jack, Ratchet and Clank, right? Big 3D worlds, always loved them so much. A big reason that I wanted to do this series at all. Okay, let's do this. We're doing it dumb. We're doing it the dumb way. Get common VRAM, and we're gonna say font load to VRAM. Now you can see our font system tries to be a bit smart, and it tries to keep track of if it's already been allocated to VRAM and only uploaded if it does. So that means that it's kind of more suited to this out of band kind of process. Like all of the rest of the VRAM allocations are designed to be done multiple times. It's kind of re-entrant, whereas this we expect it to be a bit more upfront. Okay, so this probably won't work. Oh wow, I'm very impressed. Very surprised that worked. We'll take it. We'll take it. I'm not complaining. Definitely not complaining. Okay. And our font is broken, but that's okay. That's okay. There are worse things that can happen. So, what happens if we move now, right? This is also going to blow up, but in an unexpected way, probably. Yeah, there we go. There we go. Oh no. It's just spamming the console. Doing a lot of disk I/O. It's trying to load. Oh. Oh. Okay. We're chugging, but we're drawing something. This is the next scene. We have just crashed the emulator, but that's okay. Something happened, so that's good. Like a boss says, please make an episode about doing vector units. Yeah, no, it's coming up, right? I have designed what the 3D renderer will look like. I'm just kind of enjoying the fact that I've got this Lua framework now. I want to do something fun with it before I get stuck in another deep technical rabbit hole. There's also just a lot going on with work right now, which is tricky. So, kind of prioritizing that. I'm not ready to pick up another huge, deep dive quite yet, but I will get there. I do have a lot of ambitions to do a lot of cool 3D stuff. So something weird happened when we got to this point, and we tried to swap a scene. There was a lot of thrashing. But that's okay. Let's work out why the font's broken. Font load to VRAM. That's cool. Oh, that would be why. Because load to VRAM does both. So let's actually just be more stupid about this and say what are we doing? What is it? VRAM or game get common VRAM texture font. We're gonna do what should be somewhere. Well, we're gonna do what this does, just more manually. Texture. We're gonna allocate it like that, and then when we come into our frame, the first thing we're gonna do in a frame is gonna be whatever this did, upload texture. Right? Because it's fine. We've allocated it in VRAM, now we have to upload it. And we do it every frame and we just accept the thrashing. Okay, what do we get? Still no font. And we're trying to draw a texture at VRAM address 0, which is not correct. Indeed. We actually have an error specifically for this situation. This should not happen. We shouldn't be trying to put anything in VRAM address 0. This is kind of an assumption I've made, and that's a really useful error message right now. Let's see if we can just see a better version of this error, right? Cannot upload at address 0. Can probably go a lot further with how this error message works. Okay. So, calling this should actually modify the texture itself, right? It has a base pointer which should get assigned from this. So let's just do the dumbest thing. Let's do more let's actually use our logging library. Font texture allocated at cool. And again, one of the cool things with the way we've built our VRAM system, because it's just 3 numbers, we can run it in a simulated environment. We can still see where everything is getting allocated in VRAM. So we can see the first frame buffer goes at 0. The second frame buffer goes at 286,000. The third frame buffer, or the Z buffer, goes at 573,000. It's a bit smaller because it's a 16-bit Z buffer. And then we put a texture which should come at this plus this, but instead it comes at 0. I don't know why. And I don't know why. Well, actually, I do know why. I have a very good idea about why. It's because somehow this slice is not being done correctly. We should really make these stringable. Okay, so we're gonna string.form. We're just going to write a little function to dump out the current state of a slice. Start s tail s head. And then we'll just dump slice. Okay, yet again we've forgotten to include a thing that we need. Okay. Really does not seem to acknowledge that there is anything before. So VRAM slice.start seems to be 0, which isn't good. Let me also just, log debug. Annoyingly, the debug experience isn't great here, right? This has slowed me down quite a bit. VRAM slice.start. I'm gonna have to go in a sec, actually, annoyingly. But this is 0, so we can definitely work out what's gone wrong here. VRAM.mem. Well, let's dump slice VRAM slice. Let's dump the slice we get in first, right, and see exactly what's happened here. This is the entire. Oh. Do you see what's happened? Do you remember when I said the names start and tail were confusing? VRAM slice, this is all of VRAM, right? But we're saying that we should take, where are we? Right, so we're thinking about it like this, but really what's going on? VRAM actually extends way up back here. This is just the frame buffer that we ignore, right? So, that's kind of like, that's this bit. I'm treating VRAM like it's only this, but actually there's this frame buffer stuff as well. So we should be going from the head of VRAM to the tail. And then this is head. And now we should see that these get allocated properly. Yeah, I love this. Look at all this VRAM we get for our scene. The font gets allocated at a good spot. If we want to test our fonts rendering properly, yep, here we go. We've got font. Lovely. And we can update stuff. Love it. This is cool. So we've got this test room that we load. For some reason, we're not actually setting the connector, and I think that's probably because I wasn't doing VRAM properly. So let's just see what happens if I run this now. Actually, there's one other thing I should. You know what? No, I think this is fine. Let's do it in Love2D because it's a bit quicker. We should now see there's a second repeat of the first zone that's here with slightly differently randomized stuff, and then as we get further on, a bunch of stuff's going to happen and we load in another thing, but something's gone wrong. We're calling the onload method every frame it appears, and my CPU is thrashing because this, all the like scenery and stuff gets randomly generated, so this has not stopped running. So that's good though. That's really good. That is the basis of a smooth scrolling open world. We just need to fix this reload getting called all the time. And I'm actually guessing, right? I'm gonna guess. It's this logic here. So if our X position is greater than 45, then swap the scene. Otherwise, if our game position is less than 45 times the tile width, so if it's less than some magic number, and the scene is not 0. So last scene is going to be 0 when we start the game, because the last scene we were in, we're calling, you know, scene 0, scene A, whatever, the starting point. We go to the right. At a certain point, this condition is true. Once this condition is true, we trigger this logic. We swap the scenes, and the last scene we set as 1, and then we stop doing this. So our X is now bigger than this, strictly bigger than 45 times whatever. We are off to the right. This stops getting triggered. This whole if statement, done. No. What we need to do is say if last scene is not equal to 1, then do it. That's what's missing. This setting last scene to 1 is our control to swap us just thrashing this scene swap forever. So let's try this on emulator again. Emulating a real PlayStation 2. I should fix this little lake. Like, I can actually go into my editor, and I do sometimes, just for fun. Where are we? You know, come in and actually fix up the design of this lake, because it really annoys me. Okay, for some reason that doesn't work. I've broken something else. That's good. That's good. We'll get back to this. Here is I was modifying a different zone. Interesting. And then we load. Did you see the little pause? It's good, right? And we should be able to just keep going off to the right. No, it actually bounds. Oh, that's beautiful. That's beautiful. I've hard coded that camera bound, but that is beautiful. And so then we should be able to come back, and it should just at some point jerk again, and then it's loaded another zone. Now this one has the same problem as the previous one, probably. Maybe? Something's happened. We're slowing down. We're thrashing. If I go back over here, is it going to get slower again? Am I accumulating something? Annoyingly, it can't really show us how much memory we're using. Okay. Not sure. Not sure what's gone wrong here. Does Love 2D slow down as well? Or is this like a... If we run fine here, it's probably a PlayStation 2 CPU thing. But if my CPU starts like freaking out, yeah, I mean, not even a little hitch. Also, these little lines are annoying. This is because of how my tiler abuses. Well, it doesn't abuse. It does a lot of floating point math, and so we get these slight imperfections at certain pixel fighting, right? If our camera is at a certain floating point offset, sometimes the tiles will have little gaps between them. Not fun, not fun. I can probably actually fix it just at the camera level. I can probably lock the camera to certain floating point increments. Okay. Let me make run again, and let's watch the logs more carefully. Okay, so we go to the right. What happens? We hit this magic point here, and it's going to load, and we say, cool, loaded the tiles, loaded the image, data, read it, perfect, overlay map, set everything up, loaded, love it. Now we come back, and it's loaded again, and we slow down. So something's gone wrong here. So our VRAM allocator works, that's cool. We've introduced 2 other problems. One problem is that we no longer know what scene we're targeting when we're running our level editor, and one problem is that actually let me make issues for this. I'm not using GitHub for this stuff at the moment. annoyingly, because my personal work stuff is now linked into it, so I'm a little bit scared of showing it. So I've just got like there's a Raspberry Pi just over there. I'm running a little server on it. Cool. So what's this? Select which tile map do we edit when multiple scenes active? I'm not going to write a description for it yet. I'm just going to jot this down and then probably go. What was the other issue? Hardware. After swapping scenes. Cool. Awesome. All right, so we've kept a good log of the issues we introduced along the way. This VRAM allocator works. I need to upstream the reset and the copy methods, but that'll be easy to do. That'll be on GitHub. I'm gonna make a GitHub mirror for this repository soon. I'm probably also just gonna try and like draw some of my own assets and stuff. At the moment, I'm using Star Realms as a tile set, which is, you can just find it if you search for it on itch.io. Really cute tile set, really enjoy it. But that, unfortunately, is all I have in me today. So thanks everyone for stopping by and viewing. More people watched than I expected, which is awesome. We're gonna see how this fares on YouTube with the algorithm. And yeah, that's gonna be it for me today. If you have anything you want to see me work on, stop by and say hi. I've got a Discord. Come and share cool things you're working on. Like a boss, like a boss. I'm excited to see whatever portal stuff you're doing. That sounds really fun. That sounds really exciting. Really, really cool. Like I think that'll blow a lot of people away. So thank you very much for tuning in. I could keep outroing all day. I'm gonna cut myself off there. Thank you all so much. I'm Tom, and I'll catch you next time.